Hello, Algebra 2 students. We are back today for using composition of functions. We're going to verify inverses this way by using composition of functions. So when you compose something, you put it together, right? Composition, think about music, think about English. When you have a composition book, it's a bunch of pages put together. Today we're going to use composition of functions to verify inverses. What have we learned about inverses? We know the x's and y's are switched. We know that the graphs are reflected over the line y equals x. In today's lesson, you're going to learn if you have two functions, say f of x and g of x, we're going to learn how do we know if those are inverses or not. How can we use composition of functions to verify that? So shortly on that board should come up, there it is, composition of functions. We're going to plug one into the other. So you might have f of g of x, or you might have g of f of x. So if we have f of x equals 3x plus 6, and g of x equals 1/3 x minus 2, how can we tell if those are inverses? We could graph them and see if they're reflected over y equals x. We could write the inverse of one and see if that's the other. Or we can use this called composition of functions. That notation there looks like fog. You read that f of g of x. Or you can put it in parentheses like this, f of g of x. They mean the same thing. Now, let's think back to our function notation just a minute. What did we do? We took some number that was in parentheses like this. Watch this. When we had f of x equals 10x minus 2, and we were asked to find f of 3. We took the 3 that was in parentheses. We plugged it in for the x in that function, which gave us 10 times 3 minus 2. 10 times 3 is 30. 30 minus 2 is 28. Or we might have been asked f of negative 5. And we take that negative 5 that's in parentheses, take whatever is in parentheses, and replace the x with it. So 10 times negative 5 minus 2, negative 50, negative 52. Okay, so you already know to take what's in parentheses and replace the x with it. So this is the same concept, only instead of just a number, you're going to replace that x with a whole function. So what's in parentheses? It says g of x. G of x in this case is 1/3 x minus 2. We're going to take that whole 1/3 x minus 2 and put it into the function f in place of that variable. There we go. Take the whole function g of x, 1/3 x minus 2, use it to replace the x there. So we have 3 times, replace the x with 1/3 x minus 2, and then don't forget the plus 6. Sometimes people forget to bring down the rest of that equation, the rest of that function. Now distribute. 3 times 1/3 is 1. So 3 times 1/3 is 1, so we have 1x. 3 times negative 2 is negative 6, and then plus 6. Ooh, what happens with the negative 6 plus 6? It cancels out. What's left? Just the x. Now, this will not happen every time you compose two functions, but this is key to figuring out if they're inverses or not. If everything cancels out but the x, but it has to happen twice. If we plug g into f and f into g, and everything cancels but the x, then they're inverses. Okay, let's keep going. What if we have f of x equals 3x plus 6. G of x equals 1/3 x minus 2. Okay, now we want to know, are these two functions inverses? So we've got to take g of x, we need g of f of x, and f of g of x. This is the same problem we had, isn't it? We did f of g of x already. Now we're doing g of f of x. So what's in parentheses? F of x. So we're going to take that whole f of x function, 3x plus 6, and replace the x in g. So 1/3, replace the x with 3x plus 6. What's left? Minus 2. What did we do? We took the whole function f, because it's in parentheses, we replaced it, we plugged it into g. Distribute. 1/3 times 3 is 1, 1/3 times 6 is 2. The 2's cancel. All that's left is x. Okay, what have we done? We took these two functions, we plugged g into f, and everything canceled but x. We plugged f into g, everything canceled but x. What does that mean? That means that f of x and g of x are inverse functions. This is today's lesson. We are verifying inverse by using composition of functions. If f of g of x equals x and g of f of x equals x, then the two functions are inverses. They're not always, but if everything cancels out to just the x, both ways, then the two are inverses. Okay? Let's see what's next. If they don't cancel out, if you have anything left besides the x, then they're not inverse functions. And you don't have to do both of them then, because if one of them doesn't cancel, there's no way they can be inverses. All right. So what if we have f of x equals 1/2 x plus 4, and g of x equals, okay, we're going to stop here because I'm going to change color. I'm trying to keep the f of x red and the g of x blue and the composition purple. You can tell I had a little trouble there getting my stuff together. Okay, so f of x is 1/2 x plus 4, g of x 2x minus 2. If we want to see if these are inverses or not, one method we can use is called composition of functions. We're going to take the whole function g of x and plug it into f of x. What are we looking for? We're looking to see if everything but the x cancels. So for f of g of x, look at what's in parentheses. G of x is in parentheses. Take 2x minus 2, that's g of x. Plug it into f. So 1/2, replace the x with 2x minus 2. Don't forget your plus 4. Now, distribute. 1/2 times 2x is 1x. 1/2 times negative 2 is negative 1. Bring down the plus 4. Combine your like terms. So what are we looking for? We said we were looking for everything to cancel but the x. In this case, did everything cancel but the x? It doesn't, because when you combine those like terms, negative 1 plus 4 is 3. So, here's the thing. Because f of g of x is equal to x plus 3, they're not inverse functions, because if they were inverse functions, everything would have canceled except the x. Okay? Let's try another one. F of x equals 2x plus 4. Oh, sorry. F of x equals 1/2 x plus 4. G of x equals 2x minus 8. To verify that these are inverses, or to determine if these are inverse functions, we can use composition of functions. That means we're going to plug g of x into f of x. And then we're going to plug f of x into g of x. Okay, so here we go with f of g of x. We're going to plug g of x into f of x. The whole function g of x is 2x minus 8. take that whole thing and plug it into the x in function labeled f. So you have 1/2 times 2x minus 8 plus 4. Distribute, and you get x minus 4 plus 4. What happens to the 4's? They cancel, so we're left with just x. So since that one worked, everything canceled but the x. Now we're going to go and do g of f of x. So we're going to go the other way and plug f of x, or plug the red function into the blue function. So g of f of x, take f of x, which is the red one, 1/2 x plus 4, plug it into the blue one in place of the x. So we have 2 times 1/2 x plus 4 minus 8. Distribute. 2 times 1/2 x is x. 2 times 4 is 8. What happens to 8 minus 8? They cancel out, and so we're left with x. So when we plug g into f, everything canceled but x. When we plug f into g, everything canceled but x. That means that f of x and g of x are inverse functions. Okay. If not everything cancels out except the x in either one of those, then they're not inverse functions. Every time, if they are inverse functions, everything will cancel but the x. Okay. Should keep going here just a second. There we go. I think we have another problem here. F of x equals, I don't know why I decided to put a number 3 by that one, but okay. F of x equals negative 16 plus n over 4. G of x equals 4n plus 16. And what I noticed here after I wrote this was that I have x's and n's together. My variables really need to match. So I think what's going to happen next here is I'm going to go back and fix those. It should be either all x's or all n's. You don't want to mix your variables. So we're going to take that 4n plus 16. There we go. You can see I'm going back and fixing that now, changing all of the x's to n's. Or you could have changed all the n's to x's, either way. What happened is when I was recording this, I'm so used to doing f of x, g of x, and I copied this off of paper and it was n's instead of x's. Okay, so now we have all our variables matching. So we're going to take the function g of n, 4n plus 16, it's blue, plug it into the red n. So negative 16 plus 4n plus 16 divided by 4. Work on the top first. What happens to the 16s? They cancel. Then you're left with 4n divided by 4. And the 4's cancel. And all that's left that didn't cancel out is the n. So they might be inverses because f of g of n equals n. Now we have to check g of f of n. So now we're going to take f of n, which in this problem is red, and we're going to plug that whole red function into the blue one. So negative 16 plus n divided by 4, we're going to take that and replace the n in the other function. So you have 4 and then 16 plus n divided by 4 plus 16. When you look at that, you have a multiply by 4 and a divide by 4. If you multiply something by 4 and divide it by 4, they just cancel out. And then you're left with negative 16 plus n plus 16. What happens to negative 16, positive 16? They cancel. What's left? N. So both times when we plug g into f, and when we plug f into g, everything canceled but the n. What does that tell us about those two functions? It tells us that those are inverses. Okay. This method is called composition of functions. So if you see directions that say use composition of functions to verify inverse, this is what you do. You're just plugging them into each other and see if everything cancels out. All right, there should be another one coming up. I messed up today and recorded this whole thing with my headphones were on, but they weren't turned on. So I'm having to go back and do voiceover. That's why you don't see my smiling face. All right, next problem. F of x equals. I must have gotten long-winded the first time when I was recording. Come on, Mr. Dell. F of x equals. Maybe some Jeopardy music. Do, do, do. There we go. F of x equals, or F of n equals negative 5 plus 6n divided by 5. G of n equals negative 12 minus 2n divided by 3. One thing I notice when I see this, 12 is not divisible by 5. So I'm thinking this one might not be inverses, but we'll see. So what are we going to do? We're going to take g of n and plug it into f of n. Then we're going to take f of n and plug it into g of n. What are we looking for? We're looking to see if everything cancels except the n. So f of g of n equals, take the whole function g, that blue part, negative 12 minus 2n over 3, and use it to replace the n. Negative 5 plus 6 times negative 12 minus 2n over 3 divided by 5. Now, if you work on the top, the 6 and the 3 both divide by 3, so that becomes a 2, that becomes a 1. You distribute, you have negative 5 plus 24 minus 10n. No, minus 4n. Sorry, I multiplied by 5. I should have multiplied by 2. Divide by 5. You'll see that not everything cancels there, right? Because the 24 is not going to cancel. The 4 is not going to cancel. So not everything cancels. So those are not inverses. We're done. We don't have to keep going. We don't have to check the other one because not everything canceled. Okay. You could go ahead and check the other one if you wanted to, just for caution. But f of n and g of n are not inverse functions because not everything canceled out. Okay. Now, time for another one. F of x equals, need Jeopardy music in the gaps there. Oh, change colors. F of x is supposed to be red today, right? I just do that to try to help you keep it organized. And so I can refer back to it maybe as the red one to keep you from getting confused. F of x equals negative 4/7 x plus, or minus, 16/7. G of x equals 3/2 x minus 3/2. Now when I look at this one, just looking at the problem, I'm thinking probably these are not going to cancel because we have sevenths and halves. But we need to plug it in and see. So what are we going to do first? F of g of x. We're going to take that whole blue function g of x and plug it in for x in the red function. So 3/2 x minus 3/2. Plug it in there for the x. So I have negative 4/7 times 3/2 x minus 3/2 minus 16/7. Now, When you go to distribute that, it could get ugly, but can you tell by looking that that's not all going to cancel? Do we have to work out that? We don't. Because it didn't cancel down to just the x, we know those are not inverse functions. All right, I didn't want to end on an ugly one like that, so I think I did another one. F of x equals negative 2 over x plus 1. G of x equals negative 2 over x minus 1. Okay, to verify that if these are inverses or not, we're going to use composition of functions and do f of g of x and g of f of x. So g of x is negative 2 over x minus 1. It's the blue function. We're going to take that whole blue function and plug it in for the x in the red function. So I have negative 2 over, now put that whole blue thing on the bottom. Negative 2 over x minus 1, and then the plus 1 comes from the red. Plus 1 comes from the red. Okay, now, when you look at this one, you see the ones on the bottom are going to cancel, right? A negative 1 plus 1 cancels out. And then we have a complex fraction. We have negative 2 divided by negative 2 over x. We'll wait for the writing to catch up. There we go. So we have negative 2 divided by 2 over x. You learned dividing fractions as keep, change, flip. So we did negative 2 times, flip the x over 2. What happens to the 2's? They cancel. What's left is just the x. It's kind of an ugly fraction kind of thing, but it's all right. We're in Algebra 2. We can do fractions. When you divide fractions, you keep, change, flip. Now we're going to try g of f of x. So we're going to take the whole f of x, which is red, plug it in for x in the g of x, which is blue. Again, we kind of have a big old fraction here. That fraction part I just drew a box around. That's dividing fractions. So negative 2, when you divide fractions, you keep, change, flip. So we kept the negative 2, changed, divide to multiply, and flipped, made x plus 1 over negative 2. The negative 2 on the top and the negative 2 on the bottom cancel out. So you have x plus 1 minus 1. What happens to plus 1 minus 1? It cancels. What's left? Just the x. All right. What's coming next? You need a voiceover. It's like, I don't know what to say because I don't know what's coming next. I don't think that was the end. There we go. F of x equals 1 over x plus 2. G of x equals 1 over x minus 2. Now we want to see if these are inverses. So we're going to plug g into f, and we're going to plug f into g, and we're looking to see if everything cancels out. Take the blue function g of x, plug it into the red function f of x. You have a complex fraction. The 2's cancel. We have 1 divided by 1 over x, which is the same thing as 1 times x over 1. Keep, change, flip. The 1's cancel. What's left? Just x. So we're not finished yet because we have to check the other one and verify that when we plug f into g that it's still going to cancel. So g of f of x is, take the whole red function, 1 over x plus 2, and plug it into the blue function. So 1 over x plus 2. Ugly fraction, but it's okay. When we divide, keep, change, flip. So that fraction that's on the bottom, I turned it over. The 1's cancel. So I have x plus 2 minus 2. Well, what happens to plus 2 minus 2? They cancel. What's left? Just the x. What does that mean? That means that f of x and g of x are inverse functions. Diving into the deep end today, folks. Composition of functions. All right, we're done. Goodbye.